an introduction to VCs. And before we do that, we'll give an outline for what we'll talk about. So we'll start off with talking about verifiable credentials and their role in higher education. Then we'll go into the VC ecosystem and the trust model and what that trust model is. Following that, we'll talk about the technical foundations of VCs, doing a deeper dive into the technical construction of credentials. And following that, we'll talk about building trust in this ecosystem. So the hard part, so signing and verification of VCs. And then following that, we'll talk about operating a credentialing system with the DCC. The DCC creates open source software, so we'll go a little bit about our modular open source system and how you can begin to implement your own VC ecosystem using our open source software. So verifiable credentials, and from this point going forward, I'll refer to them as VCs and their role in higher education is a VC. And I'll give you examples of VCs. I understand that some people on this call might be technically focused, but not so well-versed in the world of higher education. And then we have people here who are very well-versed in the world of higher education, but want to have a better understanding of the technical aspects of VCs. So I'm trying to reconcile these two groups. And again, if there are questions about anything I talk about, please just leave it until the end of the presentation. Regardless, though, I think everyone might be familiar with different types of VCs, examples like diplomas, certificates, badges, licenses, skills records. These are all things that people throughout the course of their lives and careers have obtained through some kind of educational system. What a VC is, though, it's a cryptographically signed set of claims, and it's based on the W3C verifiable credentials data model. It's portable across systems and wallets. It's tamper evident and independently verifiable, which makes it so great. And it also supports selective disclosure and privacy preserving verification. If you've got questions on selective disclosure, we can talk about that later in the talk. So why VCs? At least why VCs within the realm of academia. So we can talk a little bit about the current state of academic credentials. We know that PDF diplomas and transcripts are difficult to verify programmatically. Verification workflows from institutions every time you want to verify that you went to a certain school or took a certain course, these workflows are slow, they're manual, and they're expensive. And in this system, learners do not truly control their credentials. Because of this type of flow, institutions repeatedly answer verification requests, and these fragmented systems limit interoperability across borders and employers. Additionally, digital-first hiring and skills ecosystems need machine-readable trust, so that's a consideration that we need to have when building a better system. And an important note here also with the current state of academic credentials is that, as we know, universities can disappear. So in cases like those, credentials have limited longevity. So it's a serious consideration. So when we're talking about building trustworthy credential systems at an institutional scale, we need to consider what's needed. And what we need in a system like this is a way to issue credentials securely. We need to be able to authenticate identity, resolve identity. We need to be able to deliver credentials in a reliable way. We need to be able to handle lifecycle management, and that involves, so if a credential is expired, we need to be able to figure out how that's happening and keep track of it. We also need long-term operational sustainability, and ultimately we need verification and trust. Now, trust itself is a very fuzzy, abstract concept, right? We know it as the ability to have confidence in something, but in the world of VCs, there are different layers that we ascribe to determining whether something's trustworthy. Ultimately, trust comes from cryptography, governance, and institutional reputation. And a verifier ultimately decides whether to trust a credential based on a combination of 3 different trust layers. And those layers are cryptography. So cryptography answers the question, was this credential altered? The second layer is governance. So does this issuer follow ecosystem rules? And then finally, we have the reputation layer. And that layer answers the question, is the institution accredited to issue these credentials? So decentralized identity changes how identity is verified, but not necessarily why entities are trusted. So why VCs? We'll talk a little bit about the pros and why we'd want to use VCs in academia. So there are three main points that we want to make here. Universities, as we know, are already trusted issuers. They have governance systems that are already in place. They are accreditation structures. They lend to academic achievements with long life cycles. And learners, as we know, move between schools, they move between employers and countries, and they need credentials that survive platform and vendor changes. And so what VCs do is that they prevent lock-in through open standards, and they support lifelong learning and skills-based hiring. Now, I'll talk a little bit more about how VCs do that by going over the trust model. I'm sure many of you are familiar with this, so I'll try and be quick with it. So we'll start off with the ecosystem. And in general, in this ecosystem, we have an institution. So on the left-hand side, we'll have an institution and a learner. We can name her Olivia here. She takes a course, she takes multiple courses, gets a degree from an institution, and she receives a verifiable credential at the end of that from her institution, which she can claim on the wallet that she has. So this could, for example, be the LCW wallet. And when she claims this verifiable credential, she has control by way of her wallet over with whom she shares her VC. Now, on the wallet, she has VCs, and let's say if there comes a point where Olivia wants to take these credentials and apply to a job, employers can verify Olivia's VCs as a part of a streamlined job application process. And what the employers do is they'll use a verifier application where they'll verify that the credential is valid and that it hasn't been tampered with. And additionally, optionally, the employer is able to see that the issuer is listed on an issuer identity registry, matching its decentralized identifier to a known organization. So recapping the slide we just saw, we have three main components. We have the issuer, so they're the university. They create and they sign a credential. We have the holder, in this case a student, stores and presents the credential using the wallet, other ways of doing that as well. Verifier validates authenticity and identity. And then optionally, we also have an important component here, the registry and resolver. This is optional infrastructure for DID docs. I'll go over DIDs in a little bit. They're responsible for revocation and trust metadata. In other words, determining whether or not the signer can be trusted. So an example of a registry would be the DCC registry model, which James, our other senior dev, can go into in detail in a later slide. So the verifiable credentials trust model, the reason why I'm showing this slide again is to give you guys some context on the software that the DCC creates. So we have a lot of open source software that essentially creates this ecosystem. And I'll start off with just giving brief descriptions. We have the admin dashboard, which is our issuer software. And again, any one of these pieces of software can be cloned, forked, modified, and used at your institution. The code is completely open source, and I list links to our GitHub repositories at the end of this talk. The admin dashboard issues credentials. The holder is where a user, a student, can hold, receive, and share these credentials, these VCs. I'll go into more screenshots later, but essentially you can see here in the wallet that it's a way to display your credential, all the information that a credential might contain. Again, when it comes time for a user to want to use these credentials in a certain way, you need to verify them. So we've built code by way of the verifier that will let you upload credentials and have them verified. And that's using our issuer identity registry that Also comes from the DCC, meant to be used as a model. So let's take it back a bit. So why VCs? Let's reiterate. So VCs are private, they're portable, meaning they don't depend on a server. They're instantly verifiable, they're durable, they're long-lived, they're relatively inexpensive. The expenses usually come in at the very beginning when you're starting to implement the software. There's no vendor lock-in, they're tamper evident, and they're a VC, they're a W3C standard, meaning they're interoperable, meaning that they play well with other standards. So question now is how to VC? And for those of us that work in higher ed, we're pretty familiar with open badges, but essentially open badges are higher education's practical implementation of VCs. We know that they align badges with the W3C verifiable credentials. So essentially badges are almost like a subset of verifiable credentials. They enable interoperable academic and skills credentials. Open badges support rich in achievement and competency metadata, which is really important for when it comes time to apply to jobs. They represent degrees, certificates, micro-credentials, and skills. They're designed for education and workforce ecosystems, and they're supported by DCC tooling and wallets. So now we'll go into more of a deeper dive onto the technical foundations of VCs. So before I do that, I wanted to give you guys a visual of what VCs look like out in the wild, in the real world, to real users who are using this every day. So on the left, we have a screenshot of our learner credential wallet, and on the right, we have an open badge. VC model 2.0 is the current spec that we follow right now and that we support. Open Badge version 3 is the current model that we support for open badges. And our wallet allows users to pull in information or collect credentials and display them just like you see on the left-hand side. So we can see information about the issuer. So in this case, this is a mock credential from MIT. We see when it was issued, the date, when it potentially could expire, who it's issued to, and other information go into detail here. So this is the meat of the matter here, and I don't expect people to see every single bit of detail in this bit of JSON, but this is the anatomy of a credential, and I'm going to go through here. I've color-coded things to kind of give you all a sense of how the VCs are constructed and give you a sense of what differentiates them from just any bit of JSON. So I'll start at the top. Over in yellow, we have a context section, and this area here defines semantic meaning. So if you can make apart any of the lines on there, we see a reference to, for example, OBV3. So second line, that is a reference to the open badges schema, which is used to determine what type of credential and whether or not the VC is structured correctly. So that section kind of links us to schemas that we can reference. Purple section, or I guess rows, right below it, type. So that area defines the credential categories. And in this case, this is a VC for an open badge. And so we see for type, we've got verifiable credential, we've got open badge credential. So that helps us, especially the verifier, understand what the issuer. So this is the green section, the issuer object identifies trusted issuing authority. So this is information about the issuer. It can contain the ID, the type, an image as well for the issuing authority. Right below that, we have a validity window that gets defined. So you see here we have a valid from and a valid until. The valid until is essentially when the VC expires. So this is an important point when it comes to revocation, because a verifier will look to see when a credential is valid until to determine whether or not it's valid, right? Because if it's expired, we want to make clear that credential is no good because it's expired. Credential subject. So this is the section in orange. So we have an object here, and this is essentially a snippet that contains claims about the learner. So we'll have information here about the learner, like their name, their ID. And within that object, we have an achievement object, which is essentially the thing that the learner achieved. So in this case, there's a description about what they achieved. And here it says the description, someone named Lucas has successfully completed all modules and earned a course certificate in blah, blah, blah. So that's where we keep information about what the learner has achieved. And then finally, at the bottom, there's a special section in blue, and that's the proof, and that contains cryptographic signature metadata. I'm going to go into detail on what the proof is, but the proof is essentially what makes this bit of JSON a verifiable credential. So proofs, they're used for verification, but what makes a VC verifiable? So we have public-private key cryptography, which many of us are familiar with. Using that system, the issuer signs with a private key. The verifier validates using the issuer's public key. With that system, we'll know that any tampering will break signature verification. And we know that verification can happen offline in many architectures. It ultimately depends on the DID method that you're using, which I'll go into in a little bit. And in this kind of system, trust depends on securely resolving issuer identity and keys. And that's essentially what the ecosystem rests on. And using this system, we can build trust in the space of higher education. So I'm going to go in a little deeper on signatures and verification, which are two main components that help us build trust with VCs. So for signatures, we can talk a little bit about public and private keys and DIDs, decentralized identifiers. And before that, I'm just going to reiterate the issuance workflow to kind of drive home how credentials move within this ecosystem. So the Institute essentially using they can use, for example, the admin dashboard software. There is credential information that they want to include in this VC. And so they'll generate an exchange link, a deep link or a QR code that will be sent to the holder via email or what have you. The holder, meaning the student, can then take this VC, or I guess like this link, and add it to their wallet. First by sending their DID using DidAuth. The issuer at that point receives the institutional data and constructs the credential. The issuer then adds a holder DID to the credential and allocates a status and adds that to the credential. At that point, the issuer signs the VC and sends it back to the wallet. So summing up the process on the left here, we know that credential data is transformed into a VC or an open badge structure, and the issuer will sign the credential using the private key, like I mentioned earlier. The status information may be registered for revocation support, so that's a consideration. We know, like I said, exchange links. Something to note, wallet exchange may include holder authentication or binding. We can go over holder authentication. Actually, speaking of wallets, we will have a second tech talk next week on wallets. So we're going to go deeper into holder authentication and binding in that talk, as well as how credentials are securely stored in the holder's wallet. Verification can happen independently afterwards. Again, depends on the methodology that you're using. And we know that universities often prefer DNS-backed trust, obviously because it's just automatic, for lack of a better word. So how is the signing actually done? So the issuer creates credential data and then signs the credential using its private key, like I mentioned. The proof object, which I showed you earlier, and I have an example. Right? It's added, which encodes cryptographic verification. The proof formats affect interoperability and privacy metadata. They contain the signature type, which essentially is referencing the signature suite that they're using. I'll talk a little bit about that in a minute. The creation timestamp, the verification method, and this is the reference to the issuer's key, so verification method, as well as a proof value. So verifiers later with this can validate the signature using the issuer's public key. So signature suites, they define signing and verification rules, ultimately. ED 25519, signature 2020, I know, a bit of a mouthful, is common in VC ecosystems. It's the one that we use. JSON web tokens and linked data proof approaches both exist for this. And some good notes to keep in mind: selective disclosure support is emerging in this space, as well as post-quantum signatures. So more information on that is emerging as standards groups continue to converge. So decentralized identifiers. Decentralized identifiers, what they do is they identify issuers cryptographically. Did documents publish verification methods? DIDs decouple identity from centralized providers. Centralized providers, issuers. These issuers can rotate keys without changing identifiers. DID resolution connects credentials to trust material, and we know that DID support long-term institutional continuity through this system. So generating a DID and using it in higher education, how does this work? Well, DIDs provide a cryptographic identity for issuers and holders, and they're derived from cryptographic key material. Different DID methods support different trust and deployment models. For example, DID key enables simple local development and testing. DID web, for example, will allow you to do this on the web. DNS-backed methods like did.web and did.webvh align well. WebVH is verifiable history, align well with institutional trust. Tooling and services, we know that they simplify DID provisioning and key management. And in case you want to do an even deeper dive on this, we definitely encourage you to check out our deployment guide that is on our GitHub repository, and I link to it later on in the presentation. So moving on to verification. So verification is the verifier's ability to verify that the issuer is or that the credential is verifiable. And there are three components to this that I'm going to go into: tampering, revocation, and registries. So in other words, reputation and accreditation. Sorry. So verifying a credential. What does verifying a credential mean? The verifier will, in the cases that I explained earlier, will receive a credential from a student or someone with a credential. So that'll be in the form of a credential or of a presentation. I haven't gone into verifiable presentations, but they're essentially a block of credentials. The issuer DID is resolved to retrieve verification methods, and then the credential signature is validated using the issuer's public key. The credential contents, they're checked for tampering or modification. And the validity windows, like I mentioned earlier, and revocation status, they're evaluated at that point. The verifier applies trust policies and issuer governance checks as well. And then finally, the credential is accepted or rejected based on the verification results. And over here on the right, I'll give you guys an example of what verification results look like in the wild. This is a screenshot that can from either our wallet, the Learner Credential Wallet, or Verifier Plus, our verifier platform. And that essentially performs all the checks that I talked about in the previous slide, and then lets you know what has been verified, and tells you a little bit of information about the credential. So to recap, we have here a verification workflow. We have a credential or a presentation, and then the issuer resolves it. The verifier resolves the issuer DID. It verifies the signature and the integrity. It then checks status and expiration. Then there's an evaluation of trust policies, and then ultimately you can choose to accept or reject the credential. What that means, again, is depending on what fields are in the credential itself. So tampering and credential integrity. So we do know that VCs, they're cryptographically tamper evidence so that any modification will invalidate the credential signature. This way, verifiers can detect tampering during the signature verification process, and we know that integrity checks protect credential authenticity and trust. So all in all, tamper detection of the issuer. And ultimately, credential integrity is foundational to decentralized verification. So to sum up everything I just said, we have a credential, and that, with its cryptographic signature, and any data modification will ultimately result in the verification of that signature failing. Revocation. So revocation and credential status. We know that revocation allows issuers to invalidate previously issued credentials, and these credentials can be revoked due to errors, policy changes, or fraud. Verifiers will check the credential status during the revocation workflow, which I went over. And the VC ecosystems that we build commonly use bitstring status lists for scalable revocation. Bitstring status lists, James can go into later, but it is essentially a way of keeping track of the credentials institutions for revocation. So revocation preserves trust without requiring centralized verification. And also keep in mind that expiration and revocation, they'll serve different trust purposes. So to recap that, we have an assigned status entry. And this is a status entry that is related to what's issued. If needed, the credential will be revoked. And during the verification process, the verifier will check the status list, and depending on whether or not there's been revocation as reflected on the status list, the credential will be accepted or rejected. So issuer registries and governance. A valid signature alone is not enough. Verifiers need to know which issuers are trusted. We know that registries map institutions to DIDs, and like I mentioned, the DCC does have a model registry for other people to follow. Governance frameworks establish operational trust. Accreditation becomes machine-readable trust metadata. Trust combines cryptography, governance, and reputation, as I mentioned. And I've also mentioned that the DCC serves an example of an issuer registry. I am going to pass it over to James. James, do you want to take over this slide?
Yep, sounds good.
Okay. I will. You let me know if I'm too slow to move along the slide, but I've got it here.
Great.
Okay.
So operating a credentialing system, credential lifecycle management, and trust ecosystems. Okay, next slide. So maybe we can get into just a little bit of detail about expiration and revocation here. As Alex mentioned, there are different reasons why credentials can expire. And one that wasn't mentioned that's actually pretty interesting is the fact that we're shortly moving into what somebody called the other day the cryptopocalypse, which is the whole thing with post-quantum signatures. So Google has marked 2029 as the date when they feel pre-quantum signatures will no longer be valid. So they're moving all of their systems over to post-quantum by 2029. So I mentioned that because that's a reason why we would want to expire or set expiration dates on some of the credentials that we issue now, which use pre-quantum signatures. So that was just kind of an interesting tidbit about expiration. Another reason why we might want to expire credentials might be for something like a student ID. You know, the student can use their ID over the course of their university career or college career, but at the end of it, we no longer want it to be used. As Alex mentioned, revocation is needed. With academic credentials, revocation is a very touchy subject. And we have to be very, very careful about revoking credentials in that we don't want to suggest that a credential was revoked for, academic integrity reasons, when sometimes it could just have been revoked because a name was incorrectly spelled on the credential. So it's a tricky thing. But Generally, I think we found that most institutions very rarely revoke, but nonetheless, we do need to have that system in place. And as Alex mentioned, we want to be sure, though, that when we have a revocation system in place, that it doesn't infringe on the privacy of the credential holder. And you can see how this would be a problem if anytime a credential is verified, we make a call back to the issuer to see if the credential has been revoked. And if has credential A been revoked, then the issuer is going to know that the credential is being verified, and we don't want them to know that. So that's where the bitstring status list comes into play. The idea there is that instead of asking about a specific credential, we ask about a whole load of credentials. We say, give us the credential status for 10,000 different credentials. And then of those 10,000, we can go and find the one that we're interested in and see if it's been revoked or not. So this is called herd privacy. And the idea is that the issuer has is going to find it difficult to know which of those 10,000 we're actually interested in. Okay, next slide.
Okay.
I think I got to hurry up here because rapidly running out of time, and we want to take questions. I think I can speed through these pretty quickly. So deployment models in higher education. This slide and the next slide are all about basically how you set up issuance at a given for a given institution. And I think the overall point is that there's no one model. So it's going to depend a lot on what the institution's trying to achieve and what they have in place already, and also how much investment they want to make in it. Because ideally, like to incorporate issuance directly into your existing system. So, the student could come to a page, log in to the student information system, see the credentials to which they're entitled, pick one. The system makes a call back to the backend campus databases, gets the data, assembles it, signs it, and returns it to the system. But that takes, integration work, and that can be expensive. So, maybe initially when thinking about setting up one of these systems or doing a pilot, the better model might be to use something like a CSV export from your systems, put that into a completely separate system that manages the credential issuance and have the students interact with that. The point being here that there are lots of different ways to approach this. And knowing that, we made an architectural choice a few years ago to move our systems from something that we had at the time, which was a bit monolithic, and therefore a little bit difficult to configure. And we split that all out into discrete services. So we've now got this this model on the issuing side where all of the bits and pieces that together make up issuance have been split out into separate pieces that you can then take and assemble as you need them, or just use one part of it and not use the other part of it. It may be that you don't need revocation, so you don't need to use the status. It may be that all you want to do is just sign credentials and then email them out to people. So then you could just use the signing service. Nevertheless, we've made all of this available. It's all available in GitHub. We've also published all of this as NPM libraries, where that makes sense. And as Docker, we've Dockerized all of the services and we've published them to Docker Hub. And again, that was all towards trying to make this much easier for people to use. And we actually, the other day, we're looking up the numbers in our Docker Hub, and we could see that something on the order of 50,000 downloads of the signing service and something like 100,000 downloads of the status service. So it seems like people are, or that model makes things a little bit more accessible for people, and they're starting to use that. Okay, I think we've covered that. Operating the DC, yeah. So we talked about the yeah, and it's all, these are all just all of the services are basically APIs, RESTful APIs. So they're just endpoints that calls are made to, and that's actually how the services tie together. They call one another. They call the endpoints on each other. But again, an important point at the end, because these are services, they lend themselves well to scaling. So, as you move into starting to issue credentials to thousands or hundreds of thousands of people, the services, because they're discrete, can scale well. Next. These are the different services that we have. The signing service handles credential signing. Status service manages revocation status. So it actually manages both allocating a status and also later going and revoking the status, and also handles the calls that are coming from a verifier for those 10,000 different credential statuses. The exchange coordinator handles the exchange between the issuer and a wallet. And so that, as Alex talked about earlier, that's a bit of a complicated system where you've got to get the holder did, bring it back, add it to the credentials, sign that. We've turned that into a service so that, issuers don't have to take care of that part for themselves, because it can get a bit complicated. Transaction service is actually something that works together with the exchange coordinator and manages things like challenges that are sent out and signed as part of the DDoS. The admin dashboard is a system that we've got for people to issue credentials using CSV uploads to the system. So this is something I talked about just very quickly earlier. And we've got a system like that you can use and you can install on a server on AWS, if that makes sense for you, and start to issue credentials with that. In the verifier service, typically verification we prefer to have running locally. We do offer a verification service that might be used for somebody like like a large employer who's getting a lot of applications and they want to automatically verify the credentials. So they don't want to, go through them one by one and submit them to our verification portal. They rather would incorporate a verification service into their local system so that as applications come in and contain credentials, the system can automatically run verification on the credentials, making calls to the local verification service. And as it says at the bottom, these are all open source repositories and free to use as well. So please feel free to dig in. Next. Deployment models. I think I already talked about this a little bit. Well, actually quite a bit. And, oh, sorry, if you just go back one, just quickly. Yeah, okay, continue. And would you like me to turn this back over to you, Alex, or?
Sure. Yeah, we can just summarize what we've been talking about. Thanks, James.
Yep.
So there are three main key takeaways to this talk we'd want you to take. And first of all, it's that verifiable credentials enable portable verifiability, independent verification, open interoperability, and learner-controlled credentials. Also, higher education is uniquely positioned for this because institutions already use trusted claims. So it's not a new concept here. Credential lifelines are long, and verification demand is high with regards to how credentials are used to find jobs, et cetera. The DCC, third point, provides open source infrastructure, which we've pointed to, modular deployment patterns, and standards-based architecture. And with that, we're going to put some links to our resources for any developers here or people who are looking to learn more about the DCC's work. We have links to our website, our GitHub organization, our learner credential wallet, deployment guide. And if you don't want to type all of those long things, we have some QR codes here to our open source software. So these are different links to our microservices, the admin dashboard, which we talked about, QR code to the Learner Credential Wallet for you to download on Android or iOS and play around with, and Verifier Plus our system. And that's it. So thank you. We're pretty okay on time. We've got 10 minutes for questions. If anybody has any questions, I can open it up. But yeah, let us know either here or in the chat if you have any questions. Ok, sí, Mario, puedes preguntar. Espere, le voy a explicar a la gente, les voy a traducir. Mario has a question, and I'm going to translate it into English before I answer it, okay? All right, por favor, Mario, sigue. Muy buena pregunta. Okay, so Mario asks if we've considered implementing render method and what we can do with it. So render method is a new standard that allows us, and we have implemented it. You can use render method in our wallet, for example. What that does essentially is allows the issuer to link in the case of the wallet, link the VC to a PDF. So you can generate and maybe I can whip up an example of this somewhere. But essentially, if you'd envision a diploma from MIT, there can be a QR code in there, and you can have the XML for that PDF automatically. You can automatically get that from the VC when a holder receives it. So it allows you to render HTML that is related to the verifiable credential. I'm going to translate that into Spanish. Mario, si no lo sabía, en el wallet, en el Learner Credential Wallet, ahora tenemos la capacidad de usar el render method. Ya lo tenemos. O sea que se puede usar em, para mostrar, por ejemplo, un archivo por PDF. Sí, claro. Sí, entonces tenemos un ejemplo donde, espere, voy a traducir. So Mario asks if there's a way to print something like this, like a PDF that we get. I just answered yes. And he also asks if there is a way to ascertain its level of security. And I'm telling him that the PDF that we generate, for an example, has a QR code that essentially is the claim, the VC that can be scanned. Mario, en el PDF tenemos un ejemplo donde hay el código QR que se puede escanear y em, es como para producir un ejemplo del credencial que se puede escanear para verificar. El mismo PDF. Listo. Mario asks about implementation details for render method in HTML and how to do this. I believe we have documentation and there are examples for how to do it. Trying to remember if we have something off the top. I'd have to look for it, but let me
Well,
translate that first. So, sí, tenemos ejemplos. Mientras James te va a dar una respuesta en inglés, dar un ejemplo. James, please go ahead while I find an example.
yeah, I mean, maybe one of the best places to go look is the render method specification itself, which explains it all. But fundamentally, the render method is, two pieces. It's on the issuer side and it's on the consuming side. So we've got that on the consuming side in the wallet. The wallet, if there's a render method property in a verifiable credential, we pull it out and we construct the PDF and we show it. But the issuer has to put the render method into the verifiable credential. And I think maybe that's where what Mario is asking about. And there again, the specification, details what you have to put in there. Our software doesn't do anything on the issuing side with render method because that's something that's part of the credential construction. When you're making it, when you're making a credential to sign, you typically start from a template. And so if you want to include render method, you would have it in your template, and it would point sorry, you would have it in your credential template. It gets confusing because there's the credential template and then there's the render method template. Um, but you would basically either include the whole template for the render method directly into the credential, or you would point out to where it is somewhere on the internet using something called a hash link to make sure that it hasn't been tampered with when you retrieve it. Again, the specification for this is probably
TLDR.
the, pardon me?
TLDR.
Yes.
How would you summarize this in a way I can translate?
Yeah, yeah, yeah. So TLDR, look at the specification. It describes exactly what you have to do on the issuer side.
Mario, acabo de poner un enlace para la especificación. Y te comento que la especificación estaba en parte construido por Dimitri, que está en esta llamada. Él es uno de los autores de esta especificación. Dimitri, I happen to notice, so you are one of the writers for this standard. If you have any thoughts on render method, speak now. I'm not sure if you're still on, but
Yeah, so I don't think I have much to add to what James said. Like we said, basically, if you want to be able to print a verifiable credential to PDF or specify how it should be rendered on a screen, on a wallet or a verifier screen, you as the issuer either create or select from a library a set of templates, and you specify that template in the credential itself, and then you issue it, and then downstream software knows how to use it.
Mario, yo espero que en leer esa especificación puedes empezar a entender cómo es que usamos el render method en nuestro sistema. Pero sin embargo, si tienes preguntas, por favor, mándanos un email. Just letting Mario. Puse un enlace en el chat. Ok. ¿Por qué no, si quieres, nos puede mandar un email y yo te mando un enlace para la especificación y también te doy detalles sobre esta presentación. Y sí, 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 a cualquier correo que tienes. Ok. Mario will reach out with questions via email. You can reach us out, like I mentioned, dcc-team@mit.edu if there are any questions here that we don't get to. And again, if you want a badge, please email us and let us know. Mario has another question, but if there's anybody else with a question, I'd like to give someone else an opportunity to ask if there are any questions. I'll just wait a couple of seconds before I let Mario continue the question. Okay, Mario, por favor, sigues. Question is WebVH. So did WebVH the method rolled out yet? Have we implemented it?
We have
James,
not.
okay.
It's on our roadmap, but we haven't had a chance to finish it yet.
Okay. Mario, que todavía no, pero planeamos hacerlo. He asks if it'll be easy to move from did web to WebVH. As I understand it,
Yes.
WebVH is built on did web. Right?
Yes. So did WebVH authors are trying very hard to make it easy to upgrade.
Okay, let me translate that. VH es como una extensión del did web, ya que va a ser fácil para implementar. Y como le hemos dicho, va a pasar ya en el futuro. Te voy a permitir otra pregunta nomás. We're at time, so I'm letting only. Sí, por favor. Esa es una. Espere, voy a traducir la pregunta primero. So Mario's final question is actually two separate questions. He asks first if we are have considered implementing the European standard, the equivalent to OBV3, which is LLM3, which is getting used by people like POC, who provide users the option of using credentials in OBV3 format or LLM for European users. So that's question one. And then question two is whether or not we'd be willing. So Mario comes from Argentina, and he has a question on whether or not he can, representing his institution, can become a pilot. And as you know, the DCC is a consortium of different universities. And so ultimately, I'm going to have someone answer the question on LLMs, because I mean, I'm going to answer the question, and then Dimitri and James, if you have anything to add, you're welcome to it, because we're at time. So those the questions were, can he participate as a pilot, essentially? And that's more of a question for Carrie, so I'm going to let him know that. Mario, para darle una respuesta, al momento sobre usando los LLM3, igualito como implementar el WebVH, eso lo consideramos para el futuro, pero al momento no estamos trabajando en eso. Pero no es para decir que no lo vamos a considerar. Y sobre la pregunta de ser un piloto, eso también es una pregunta no necesariamente para nosotros, los que hacen el desarrollo, pero para Carrie. Entonces, de nuevo, te voy a aconsejar que le manda un correo para que ella lo recibe con ese asunto, a ver qué dice ella. Bueno, sí, ok, gracias. Y tenemos que terminar aquí la presentación. Entonces, muchísimas gracias, Mario. De nuevo, sí, sí. Listo, sí. Okay, bueno, Mario, entonces nos hablamos. Thank you everyone for joining our tech call. Again, if you have any questions, feel free to reach out to us. You do have our contact information. We hope to see you at the next talk. That's going to be on wallets. I'm going to stop the recording now. Have a good rest of your day, and thank you.
Recording stopped.
Bye, everyone.